Frankie, Frankie, you need to get out of your seat.
At baseball or at someone else? But those aren't that bad. You know what? How many times did you? Oh, you are? No,
I think
you.
you can go to advisory and then see what issue it is. So it doesn't come to that.
Three, Oliver, Matt.
Yeah, say go. Say go. Oh, that's.
Mason. Aiden.
Are they waiting for baseball or are they waiting
No, I did not mean that. That doesn't mean that. That does not.
Camden and Zoe. Got a lot out. All right, guys, there was a bunch of handouts to pick up, so make sure that you have those. But before we get going here, one last chance for your homework to turn in. So from 2 classes ago, the circuit product rule, quotient rule should be number 27 in your binder. Most of you guys turned that in the Google Classroom, but as always, I try to give you a chance to turn in a hard copy in case you had any issues turning that in correctly. So if that is you, put your name on it and come turn it into the box right now, please. Okay, everybody got it in Google Classroom? Okay.
Can I have someone with crutches carry their stuff inside and I can get their email or their counselor to email you?
One more time?
I furnish crutches and they need help carrying their stuff. Can I get
Okay, that's fine. Go quickly. Take the pass, please. They're going to stop you somewhere. Okay, so one of the handouts that you have is number 31, and it's 4 Khan Academy questions. So I looked over the questions that you guys missed and my third period, because I have a third period to talk to this class as well. And I found every question that was 50% correct or less. And I figured if that many people were missing these questions, it would be worth looking at for just a minute. So we're going to go over these 4, make sure that there's not something unique about them. It is chain rule questions, but we need to all be on the same page there, because there's nothing, in my opinion, about these questions that make them more difficult than what you should see on a test. So need to be clear with that. Then I've got a quick little card sort activity, and then all the other 3 pages make up your Unit 2 review. And so when you finish the card sort activity, you can start on that, and we'll talk about it more once everyone's there. Okay, but the Khan Academy, we got the very first question was the most missed question. Right next to the number, I put the data on there so you could see. Why we need to talk about it. So in this one, only one person out of 12 got this one right. So again, there's nothing uniquely difficult about this one in my opinion. So just in case there's something weird about it, we need to get it cleared up. So chain rule, I'd like some participation on some of the next questions, but on this one, chain rule says take the derivative of the outside. So that would be bring the power down lower the power by 1 with the inside plugged in. So if natural log was inside, it's still inside. And then we had to come back and multiply by the derivative of the inside, and this is one you need to memorize. What's the derivative of natural log of x supposed to be? So that makes the answer what? Okay. Multiply those fractions together, you end up with choice A. So power rule in the big picture, come back and multiply by the derivative of the inside. Everybody okay with that one now? Okay. I would say this one was way harder, so I'm not sure why it's a little bit better, but 3 out of 15 people got this one right. Again, I know some of that might be just like you missed a question and you're just trying to get it to reset, but doesn't Khan Academy have like a reset button now where you don't need to do that? Okay, so I don't know if everyone uses the reset button, but this one was just a little bit harder to simplify. So if we rewrite this as e to the x to the 1/2, the derivative of the big picture is going to be power rule. Bring the power down, lower the power by 1, times the derivative of the inside, and the derivative of e to the x is e to the x. So technically, this is the derivative. That's all that there is to it. It was just a harder one to simplify. I would personally say, let me move this stuff with the negative exponent down to the denominator. Multiplying puts it in the numerator. You can think of these as two big fractions. And then I think if you have issues moving forward on this one, you need to maybe combine these together. When you take a power to a power, this is when they get multiplied. So this is the same as e to the x over 2. And then you can say base of e, when you divide things with the same base, you subtract the exponents. So x minus half an x would leave you half an x. And then you can turn that back into a square root. And eventually you end up with choice B. So that one's a little more understanding, a little harder to simplify. But certainly within what College Board expects us to be able to do. So, any of those steps you want me to repeat again? If I put this one on the test, everyone's going to get it right?
Can you just redo all of the simplifying again? Or like the last part?
I won't, but I will let you tell me what to do, and then I'll steer you. Okay, so here's the derivative, so what would you do next?
Put like the negative exponent on the bottom, like that e to the x on the bottom.
Okay,
And then put the positive one on the top.
okay,
And then add the 1/2. Or,
One.
Yeah.
okay. I did the same thing.
And then
How would you deal with this?
that's the thing that turns into x over 2. Is that what you said?
Okay, so let me phrase it in a different way, because it sounds like if that's where you're slowing down, it's an
Yeah.
exponent property. If I did x to the 3rd squared, to square something means you multiply it by itself twice.
Mm-hmm.
So you get x to the 6th, right? So when you take a power to a power, you really multiply those powers. That's what you're doing. So x to the 1, e to the x to the 1/2, you can just multiply those and call it e to the x over 2.
Okay.
1/2 times x.
And then I think this is where I got confused. This is where you do, like, because it's dividing the x's, you,
Dividing things with the same base, what can we do with the exponents?
subtract them,
Okay, so 1x, take away half an x, leaves you
half an x.
half an x.
And that stays at the top because it's positive. Yes. Okay.
Yes. The 2 should still be there. These two combined into that. And then the last thing was you can change this e, the part over 2. What does that come out to be? Or how can I make that look different?
With the square root.
Okay, so square root, it's still to the x power and over
Okay.
2.
Thank you.
Other questions? Again, the more practice we ever get to, obviously the better. That's always the case in math. But if it's something like this, you guys need, I know you're tired of me saying it, but you need to write out in words what happened, write it on the top of your page. You probably will never see this exact same question again, but you're going to see where you're expected to know to subtract those exponents. So it's fine if you're rusty on that rule from Algebra 2, but you got to pick it up as it comes along. So. Okay, the next one is a little bit better. 7 out of 16 people got this one right. So if I try to take the derivative of natural log of something, how do we do that?
It would be 1 over
Okay, so the derivative of natural log of x is 1 over x. So the derivative of natural log of something is 1 over something. And in this case, the inside would be square root of x. So I could bring the power down, lower the power by 1, maybe move this guy to the denominator. And what is square root of x times square root of x? So our answer should be C. By the way, this is not yesterday when this came up in class. When I did this derivative, I went straight to this. That's not one that you guys need to memorize, but we take the square root, the derivative of the square root of x so often that it's kind of a nice little shortcut to know what that is. So, okay, any follow-up to that one? Okay, and then the last one really surprised me, although it was not terrible, 3 out of 9 people. So how do we take the derivative of cosine something? Okay, negative sign of the something. And then chain rule says I need to come back and multiply by what? Because that's the derivative of the inside. No more, no less. You have to know the derivative of cosine is negative sign. And you have to train your brain to consider the derivative of the inside every single time. Every time you forget to, it's not going to work out. By the way, and I know I said this last time, but look what happens if you forget the chain rule. If you forget the chain rule, that distractor answer that's not correct should be there. That should be the most common distractor answer, because they're testing to see if you remember the chain rule. So. Okay, before we put this aside, any last questions? Again, I'm just trying to point out some of the ones you guys struggled with the most. Okay, you can put that away in your binder. The next thing we're going to look at before I let you move over to the test review is this card sort activity. So you don't need to do this on paper or anything, but I might have to ask a couple of you guys to move around because this should be a activity you do with your neighbor. So let me get them all passed out and I'll tell you process is going to be. You two work together on this? Yes. What? Okay, so in this pack you've got some green cards and some yellow cards. If you look in the top left, it'll show you that the green cards are velocity cards, velocity graphs. And in the top left of the yellow cards, they're position graphs. So what you need to try to do is match up the position graph that matches up with his velocity graph. So the part that you need to remember about calculus, what's the connection between position and velocity? It's a derivative of the position, and derivative, the way you're going to determine the derivative is by slope. So looking at the slope of your position graphs should give you some hints about which velocity graph it is. There's no tricks in this, there's no extra cards, everything matches up to one. So go through it. After a few minutes, if you are struggling getting started, then let me come and help you. Otherwise, let me check your answers when you're done. And you can take as long as you need to on this, but the sooner you get them right, the sooner you can move on to the test review, which will be less This one.
Yeah. This is negative sign. I mean the negative. Or
Maybe it's this one.
a speed of -2.
Oh, yeah.
Would it just go -2?
Oh, this one's
This one's could also have the value there. I think it was this one.
Yes, his position at that x should have a slope at that distance of -2. Yes, exactly. Like not close.
Oh, that was, it's not, oh wait, it's opposite.
So this is sun.
Oh wait, is it?
It is, but you don't want to know that.
Okay. What do we need to do?
That one's,
Well, thinking about the slope of the position tells you something about velocity.
yeah.
The derivative of position gives you velocity. Derivative just means slope. So looking at your slope of your position should give you hints about which velocity. Yes, and of course it gets easier. After you get a few behind you, you've got less cards to look at. So the first few should be the hardest.
Okay, so you look at, you said 3 is still 0. So you have to go right? Here's one, here's one. Then we need to do some other numbers. So just
Oh, you.
Like when you say slope,
And
like
then-
we're looking at,
This one should be like
It's just the derivative. But it's kind of hard to tell.
and here that's slope of 1. Like 1.
So the derivative would be like starts at 0. So it would be like that. Something like this. Yeah, pretty sure.
Maybe these two.
No, I'm kind of just looking at like the position starts at 0 and it's going.
faster towards the negative direction and slow down. Velocity.
What we're doing is so the slope here is at 2, where at 2 it's
I
at,
think this one is.
not the slope is 0, but at 2 it'd be y. You understand? And then if I like 3 of those cards, that can work with this one, and so say, okay, and then at 4 the slopes. Oh, it's like what, 1.5 or something? So then we find the boy is still 1.5. You know what I'm saying? They're not the same thing, but a lot of ones.
That doesn't quite work, but
So we need another curve
I think what you do is just narrow down. Think about when the slope is 0. That should be your whole answer. Always which one is velocity graphs are only across Probably is that but it's still positive. Positive slope. So like this slope here, not exactly the same as this. So that should be okay. I think that these are probably, I would take these two together. And then the others are okay. And then narrow down. Okay, so let's do one more. Make a difference, that doesn't matter. Okay. So, when is the slope 0? At 2, it has a slope of 0. So you can find this
one's also always.
at 2, you need one that's in 0. So this one.
Okay, this one. Where's like their parabola?
No, that's and then 4, it's at 2-ish.
Yeah, that's true.
This is negative. This is the starting one of this. Just negative. This is like negative.
So when it starts positive, slow down to 0 is flat, so positive to 0 to decrease. So that was something similar to this. Yeah, but it's, look, that's always negative goes to 0 and increases the slope. Yeah, I think so.
Yeah, and when it reaches 2, it stops. Okay, I feel like maybe we got this one wrong.
So it's negative, not 0, it's negative. Should be something like this.
So yeah, this one should look something like this one's
Very similar. I think it is. I'll line these up as similar.
These are all, so scramble these back up, put them back in your bag. And then you're welcome to move on to your industrial. And get as much of that done as you can, so everybody can finish it.
So, just like where
Okay. It's 0 at 2. And it's 0 at 0.
So then take it.
I think it is. Okay.
But then there's only one of them is negative.
Okay, so what you're saying is that could be a problem. This is probably a cubic, but it could be like a fifth root. Or just like this is probably quadratic, but it could be like so if you pick one, think about the slope of position slope is like derivative and derivative of this, right? So from here to here, the slope is positive. So velocity needs to be positive from x equals 0 to x equals 2.
Yeah.
And do you read these graphs differently? It's like from 0
I'm looking for, this is positive slope, so velocity needs to be positive from 0 to 2. Here is 0 to 2. Sometimes velocity is positive, but the x-axis, sometimes negative, so it can't be that.
And this one's always
Can't be that one. So that's
Yeah, that's not possible. Wait, no, okay, yeah, I got those ones. That does start right.
okay, well, let's just load those up two. Okay, so that means the velocity graph is equal to technique. That looks like the only time you got a horizontal line is where you have one x-intercept. So it's sloped positive from 0 to 2. One x-axis is 0 at 2. And is it positive again? These are probably the other side. Let's do one more. Pick a different position. Yeah. So
This one's fun.
negative slope. Or let's start off with the start. Where does it have a 0?
yes, 0 to
This counts as zero.
I feel like this one's not value slope.
Yeah.
Now I'm just not sure what
Negative or slope positive. Where's the slope 0?
Wait, which one does this one?
This is 0 with 2.
No, that one's not 0. Yeah,
And then
no.
it's 0.
Right here?
Or negative
Right here.
Oh yeah,
2 times where the slope is 0.
that's 0, 0.
How is the slope going from positive to negative? If it's not 0, it's okay, so there's 2 times the slope 0. So your velocity should be 0 at x equals 1 and x equals 3. Okay, like maybe this one. So, or if you do this one, it could be 0.
It should be this. It should be
Narrow down to 0 like that.
right?
Yes.
The fact that this has a negative slope of 0 to 1
No.
means that it can't be.
And it'll start at 0.
Okay.
Right? We'll start at 0.
Negative.
We definitely messed up something.
If it's below, then we get 2.
Yeah.
I don't think it's
How do you know it's well, because it starts out negative, so it has to be a downward slope to start out. Right here, that's actually the
Positive.
Oh, we're part of the 0.
Zero to 1 is out.
No.
I want negative 0.
Yeah.
Wait, no, this is negative.
Right, this should be 0.
Let's
take this one aside for now.
Negative slope, negative value. So we need 0 to like actually negative 0. That one stop. Positive slope, positive value.
Yeah, it's probably one of these two.
0 slope, 0 value. Negative slope, negative value. Okay, then those are probably
Yeah,
right.
it's probably one of these two. Yeah.
And then these two actually less.
Mr. Thompson? Help.
Okay, I'll be there in a minute.
Has to be how many is all negative.
Wait, because 0 has a slope of 0.
Yeah, I think
Why are you thinking about the slope of velocity?
Wait,
This one about it, it's on the right.
This one. At 0, it has a slope of 0. At 4, it has a slope of 0.
And close down. Close to 0. I mean, it could be like this y is negative.
But basically, it's just like this, right?
Why?
Because it drops and then
Yeah, I
comes
think-
back up.
To me, it looks like it's basically always negative.
Wait.
And then it's almost 0 at
Okay,
these, right?
okay, maybe.
Maybe see this.
They're after the
Other way
basically
around.
negative slope. Oh, so where's the, velocity that's always negative value?
This slope starts out.
Oh, yeah.
Always negative. Well, actually, no. This slope starts out positive. So
Easy.
it
Oh,
goes
no,
So it's not something to match them up with this.
They do that.
to zero.
So you're saying like you really, really, really have to work on
Yes.
the
Like, so the slope is positive, not this. This is slope positive.
Yeah.
You're gonna get over
So this one,
And whenever this is
And
zero,
also
positive zero.
this one, the slope is 0 at 2. So these don't match up, so we mess up on
If the slope of this is just like the number. Once you get the
So
slope
you
here
find
would be
one that
second
has
derivative, that's what I think.
at the 0 at 2.
Try to make that correction. That's not you should try it on your own.
And it starts with a negative.
Positive slope, positive value, negative zero slope, zero value, positive slope, positive value. Probably. It's not like they would go together.
Wait, hold on.
Where did? Oh, you did by wrong.
There's a 3, it should be 0. Wait, it is 0. I want it to be 0, it is 0.
Trying to work backwards.
Yeah.
80% is way better.
Yeah.
This one starts.
Negative, is that? I'm asking that.
The negative slope.
Yeah,
Oh, so this is a negative slope. This is the negative slope, this is whatever it is.
So one has a slope of 0.
So it's like negative to 0, positive,
3 does a slope of about 0.
and then it starts to.
Negative zero goes down.
And then here it's going up, right? So that's a slope of positive.
Yeah.
And positive value. Positive slope, positive value. I think about it. This is trippy.
I somehow passed this.
I need to extend it. One sec, wait.
Like another
Yeah,
2.
this works out. What's up? Yeah, you need to look at yourself. You get
Yeah.
Yeah, I think so.
Oh, wait.
Oh, it's called, okay.
You got this one. Oh wait. Are you looking at one that matches this? One that matches these, right?
Position when the graph
So
reaches.
you're trying to get one that matches this,
zero
right?
and then stops.
Sure.
The velocity should be at zero.
I mean, yeah, we got that.
Well, I think this
But I can't find
I think
anything
these
else
two
with
look
mine
good.
can do that.
Right? Wait, but that's wait, yes, yes.
That's not
The
it.
problem is, it's so confusing because you have to think about the slope here, but then you can't think about slope here. You just have to think about whether it's in the negative area or the positive area.
It's not right.
We try those again, recheck.
It's weird to try to think.
Oh, that's right. No. Because
I know, but I gotta check.
this
Oh, wait, never mind.
has negative slope.
Number one goes with.
Look at this first, don't look at that. You need one that has a slope of 0 at 2. 2 has past 0. So it could be this one. Right, it has a slope of about 0 at 2. So then here it has the value.
I think the best way to double check this is see where they intersect with zero, to see if there's a problem.
Yeah.
There you go. Yeah, that's where.
Then 12.
Okay, these two are the ones you got wrong. So
Yeah.
put those away, scramble them up, put them in the bag. These you need to retry. Scramble them up so you don't remember what you did.
Okay.
The rest of them.
Thank you.
Hold on, let me check yours first, because there should be none.
I can ask them to come down and then see.
Okay, this one. Double one, so that is bag, and then start a few questions. What run did you put with?
No, I feel like this one has to be with
like this. It's 2, 3, 4.
because it's the only one with local.
And then I looked at the smart one, and then I looked back to projection, so please look confused. You look at the projection.
That would make the most sense.
Her face, look at her face, but this is like, alright, so look.
Positive slope.
Yeah.
We have 4 that we haven't done yet, but.
I'll check them after you do the 4.
There's no match.
Sure.
That's fine.
Well, then we gotta reevaluate.
Okay, let's just.
All of ours are on.
Okay, so part 1 deals with
Yeah.
We know so many.
3, 4,
Wait, no, it's plus 2.
5.
No, it's minus 2, you're
I don't know
right.
how you take this.
7. Okay, 9. 10. 11. Yes, first unit. 12. It was.
It's usually E, because you're getting this.
Okay, but we have.
This starts at 2. This
The guy doesn't teach.
No, he doesn't. Yeah, you're like. Had that, so you need to replace the rest are fine. You can scramble those up. Okay, so I'm scrambling these up, so you just switch your answers. Y'all ready to check? Okay. Card 1. What round do we have?
I think so.
You know, that's like passing.
Yeah.
Hard one.
You wish we did this stuff. 6. Every time you play games after class.
7.
Just play group games.
Like, when you just.
Liliana just read.
Yeah.
We just go out and then this stuff last year, free time. It was like me, Diego for dude.
You got it. I guess you can scramble these up, put them back in there, and then
AJ.
start a few questions.
All of ours are on.
Because,
They probably would.
like this one, it is going negative, but it's slowing down, it hits 0. And then the positive, it's like this point, and it starts slowing down again. So this one starts at negative, and then it's moving to 0, the velocity, and then it speeds up, and then hits 3, and so it's slowing down again.
How did you guys feel? What's up?
Yeah, I guess so.
Well, it's 'cause I'm asking about the other parts. You're gonna write everything on a post-it note, put it where you got it, and then another question.
Yeah. Scramble those up, put them away.
I think we fixed it.
Okay.
We only have 4 cards. They have a lot of cards.
Just work the questions here.
Okay, so those, okay, what we will do.
Huh? Oh, what did you say?
Goes in the right direction.
Those are right. So scramble those up, put them away. So like these seats, you had to split.
Well, I'm at 27, so I don't make it up like that. At least start letting guys copy and paste it.
Try those few, so we're like,
Can we play chess? Yeah, that's great. Oh, yeah. There's no hiding.
Yeah, yeah.
What's 30?
I should have memorized situation.
No, it's 8 days.
This
What about like plant-based fruits?
and then like those do like and then start on
Yeah, we started talking about AP environmental science.
Oh, this
you
one.
gotta have all that done by class.
And then it turns. This one's right.
I would have thought it was less, but if you're not.
No, I think it's seven. It is at 1 4.
And then it goes So it goes down.
You understand why you had to mix it up? Like whatever. Put them in the bag. Start
Wasn't it
So the derivative of position is what, let's say I give you info about velocity. The only way you're gonna know about the derivative of position is what velocity. So when you get close to this guy to zero, no, those are values, not slopes. It doesn't have a slope, but a zero. Zero is one of them. Okay, so that slope of 0 at 1 and 3, the velocity graph should be 0 at 1. So it could be 0 slope, 0 values. Okay, negative slope should be negative values. So from 0 to 1, it needs to have negative values. It's fun to the x-axis. You're thinking slope here. If you're thinking of slope for velocity, you're actually talking about acceleration, which is not slope of these values are vectors. Negative slope, negative value, below the x-axis. Positive slope, positive values above the x-axis. Negative slope, negative values below the x-axis. And then try that one. I'll come back one more time. But I didn't say anything different than stuff before. You got that all sorted? That's how you think about there's one of these I have where I don't even tell you if the car's velocity or acceleration or position. You'll be following it. Okay, start on the test.
Just wondering, imagine that this is 6 and is x.
Yeah, everything is more.
6 and then you plug that in over x in the function.
It's math. Math on my list. In English and reading is like that.
Guys, get started on this.
I guess it's like more homework.
I think we got this. Let's see. I agree. Disagree. Agree. 8. Should be good. Yep. Yeah, you got it figured out now? Yeah. You really have to force yourself to focus on slope on one and values on the other. If you start thinking of slope on both, it gets real tough. Fix those up a little bit and then
I don't know, it's like, I won't do well this year with all my classes.
that would be the section.
Like, I'm in this class, you have dy over dx,
First solution, and these are part of the dx
I don't know, her songs are one
They are.
Class period.
I don't know what. That's what everyone's ready for.
This is all over there.
cosine of 0
I
is
realized that it's so much better.
So when you do y over x, you're talking about right
g
to the right.
0.
The slope.
I realized that like sophomore year
Yeah.
with
No, we're getting close. I'm trying to tell you, f of x is.
I just enjoy it.
That's good.
Different way of saying that prime derivative is dy over dx. Two prime marks mean second derivative.
It's
And
just-
also this thing does.
I think this year might actually kill me when they put
And then you gotta take derivative. That is second time we find the second derivative. That's the hardest one. So like when we write you to, when we ask you to write the equation of a tangent line, you need to start with one slope, and then you need to multiply with 20 and 5. This one's usually given to you, so once they given, we need to tell you where it is. The derivative at x1.
2 to the negative 6.
The derivative usually has x1, so we only care about the derivative at x. No, just x1. If you say f of x1, that's a y value. Yeah, you're right.
8, 6,
Okay. Sometimes we just tell you the point, is that like 1, 3, is the formula 1, 3, y1. But sometimes we just give you x1. So how would you find the
Yeah, you
y
can do
value?
that, or this is the hardest way.
What and what?
Because they want you to do it.
Or no, the
You
original.
know the product
The original.
rules
There you go. So identifying that the function's good for finding points, the derivative's good for finding slopes.
at least on
Oh, I didn't read it.
This is the derivative here. It's fine, you can put down what you want, but when you check your answers, you need to see why it's not different there. I just went over that work, y'all work on that together.
Next one is
When you're, can you, maybe explain how, like, which
Huh?
points equal, like, the x? I know that x is like the function of the graph.
Back there.
This is here, really.
Okay. Okay.
And you're trying to figure out which one of these would be the derivative.
Okay.
So it looks like you're trying to use this. So where you take like x plus 8 into the function.
Or what's the h?
H and delta x.
I struggled.
So,
Okay.
This delta x, this just means the change in x. Sometimes we say x.
Okay. So it looks like that goes in here.
tangent line, the slope of the tangent line.
This is 2x plus 4 and this is still 2x. Or I'm sorry, this is 2x squared and this is still 2x squared. They didn't plug in an x plus 8.
So that one.
Oh, wait. 3 times.
So the h is the delta x.
Yeah, that's the delta. You can change all the delta x's to h's.
So it would be like this one.
Okay, so here's 2x plus 8 squared plus 4. So that's the function with x plus 8 plus n. Then you're supposed to subtract the entire function.
Yes.
And then you're supposed to put it over h.
Okay. That makes sense.
Okay? Well, what about,
Because this one's kind of, what is the difference?
exactly, what is the difference?
Oh, right here?
It only exists once. That's why we had the big limits before we did this.
Plug x into this equation, so there is no x, so it's like 0.
Okay, was there any more cards out? I got them all. Okay, let me talk about the test review real quick because it does look fairly lengthy, but it is also kind of spaced out quite a bit. So if you look at the top of the front page, this isn't really a ton of practice in any one type of question, where you might need to practice 2 or 3 types, another 10 or 20 times. Other people may not need to. So short of me just giving a handout that's a workbook and making everybody do every question, this is supposed to help you kind of narrow down the topics. So the first topic was the definition of a derivative, the things you have to know, and then there's 3 practice questions. So by the time you do those 3 practice questions, you're gonna know if that's something you need to try to relearn, or just for review, or if you're good with it for the test. I'm sorry that 4 and 5 didn't print out great. I did try to start it, but if you know that that's a weakness of yours, I would probably circle those questions as you realize that you needed help or you missed them. I would probably work them again before the test next week. But if you want some unique practice, right below that, I have a bit.ly link that's optional, but if you know you need more practice there, then you could go to that link and there should be some practice. Then it's got power rule, knowing what the power rule is, practicing it once, some extra practice, product rule, writing what it is, try it on 2 questions. That should give you a hint if you've got it down or not. Quotient rule, write what it is, 2 practice questions, give you an idea if you know what you're doing or not. Chain rule, write it down, question or 2 practice. So again, it's like the whole front page really only has 7 questions. So it looks a little bit more lengthy than it is, but this will help you figure out which things you're comfortable with, which things need to be reviewed, and which things you need to relearn. So you need to get as far through this as you can in class. You guys got about a little over 40 minutes, right about 40 minutes. So that should put a very big dent in it. But what you don't finish in class, I have to ask you to do for homework, because next time I see you guys, I need you to know which ones you need help with. If you haven't tried it all, and you don't know what you need help with, and you're missing out on that opportunity. So, okay, so that's it. So work on that. I'll come around, give out some help. The website does have the solutions if you want to check your answers regularly. Obviously, you need to check them at some point, but just try to get as much done as you can in class so that you have little or less homework. Okay, so this is one way to add over the derivative, that's the other way. And then if it's a squared y over x squared, that's asking for a second. Okay, you need to be on today's stuff.
No, okay. I'm trying to practice.
Now's not the time for that. You need to be where we're at. You can't be behind every time you miss a class. You need to join us with this, and then that's your make it for you.
Can you show me how to do this or no?
Not right now, no. Sign up for prime time or stop missing class, I guess.
So this 2 to the 3rd is the function.
It's the function, but they're plugging in the value into it.
Oh, okay.
Sometimes they do, sometimes they don't.
So the function is how do you know if they're plugging in?
Because they're on the X in.
Okay.
Wait, I didn't get the
Oh, you want this one?
The function
But it's
is on the X.
right.
Tell me.
So that narrows it down to 2
all I know is
choices.
it's so that I'll remember that and then
So the next step
And then the X value they're plugging in is,
2x squared minus
so that's what they're trying to
already
find.
know
Not trying to find.
is this is that
And
one.
if you do this, 2x squared minus 4 minus 4
Standard is over 8, only limit of 8 plus 0. This one usually has 2 parts of the denominator, and it's not necessarily approaching 0.
Oh, so. Put it in, just write down the slope, put slope form. So it helps you write out slope, whole slope.
Anything y'all are stuck on yet that I could give a reminder to?
Just variables. And then
You're gonna have to show work on this.
known variables, like, you know,
Any that I can help with yet?
okay, so, you make your derivative and then you plug in the x value to find the slope.
Y'all doing okay right now?
Yeah. Did you say no?
No, I'm good,
Okay.
sorry.
Divided by 4. Is the slope at divided by 4.
Thinking? You want to do stuff?
So you plug that into
Okay, what are you looking at?
You know what? Oh, I was trying to.
No, make a power rule.
Okay, sorry.
Alright, so now this one's more like this or this?
I know.
Okay, I agree. So right here is supposed to be the function. Okay, so since there's no x there, I know that they're plugging in the number. So I would say the function probably 2 to the x. So that's gonna narrow it down to your choices.
X
And if you square that,
Okay.
if you square
And if they're plugging in 3 in for x, then you want the derivative at 3, not at 0.
Memorize that one.
So this is the one that says your derivative.
and then distribute that.
You're on different page. Why don't you start by
This one's one.
Okay. You don't have your timer with you?
Well, I would have used the actual book.
You'll put it in.
You wanna do it?
Okay. Just skip it for now.
Yes.
So this one, yeah, I thought so.
You can tell me what you did. If you know how to do it.
Yes.
That's good? No, but
Yeah.
anything I can help you with?
I don't know how to do it. Two, almost on the kind of work. So it's gonna be negative sign. That's it. Does the 4 come up? Or no?
Well, I guess you could do it like that. Are you in the class?
Or is the x on the 4? Is the, sorry, is the 4 on the x or the sign? Is the power to the x or to the sign? Oh.
I like okay.
So it's gonna be negative, so it's gonna be cosine.
Yeah.
Yeah, but
someone messes up and like something like that.
You're stuck on something and you need a hint, call me over as I come around. Absolutely not. Oh, I was just wondering if quality could be negative. Could be positive or negative. But yeah, you're on the right track. The exact word is important.
The direction was going in that message.
Oh, that's it.
I just did explanation.
Well, over here, you're not getting 0, right? So, if you imagine this one, like a 0, and then you make the numbers, we can mark it as 0. But I'm saying, if you really have a number, let alone an x minus 0 at the bottom. So how can it be b?
Do you get it the same answer?
That's fine.
It's still the same.
No.
It's not gonna have to ask me on the bottom, it's gonna be.
But it's like, I expect one of them to do
Yeah, it should be x minus the number you're trying to find the derivative of. So they didn't have to show the minus 0 was minus 0. But they did.
You guys ready?
So it should be
A, because here's the function.
60.
Here's the function of the derivative you're trying to find. So the cosine of 0 is,
Full pin to 1.
and it's supposed to be over x minus the value you're trying to find the derivative of. This guy didn't have to do it.
Oh.
Pretty hard to do.
Yeah, I'm just gonna,
Yeah.
Particle is one of two things that will flow.
Supposed to be strong, or
Which equals
And you're
one.
really doing it analog
Or 1 minus 1.
That would be my, like, okay, so we're not gonna in this case, it matters because this is cross, this is not gonna be 1 unless this is 1, so we have to have. That one's not super important.
yeah, it's like the gap.
Nothing I can help with, slow it down a little bit.
So you kind of just opposite of baseline, right?
Remember expanding and condensing logs?
Oh.
So you could change this to natural log of x minus natural log of x minus 1. Yeah, because otherwise you gotta do.
Yeah, I got
get rid of
here
the
and I
whole
was like, I
thing,
don't wanna do that.
And then the chain rule is gonna be a quotient rule. And then the quotient rule, you're gonna have a chain rule again. So in theory, it should work out. I wouldn't go split out. I didn't have to. I do.
Yes, you do.
Okay.
You want to tell them something on test review, hold me back?
No, I'm good.
Put pressure on.
I'm good.
Again, I know this review seems long, but notice there's only like, I don't think there's more than like 3 of any one type of question, so.
On this one, I understand that the derivative, when you simplify it, maybe you do that next one, you know, this is
Well, you can't divide
See,
out
I
currently,
thought,
because
but
if
I
it's
don't
minus,
know.
you can split apart your fraction. You can put this over this, minus this over this, and then you can simplify your left fraction. But you can't cancel these because then the 2 is supposed to be over 2 squared. And
Okay,
you're-
but if there was like no two, then you could.
Yeah, then you probably should.
This is
I mean, it's just like,
Is there a side you put that? Or
it's the same thing as this. I know it's a little bit harder to see. When you got 3 X's here and 2 X's here,
X.
yeah, it's like 2 of these cancel out these. But what you're really doing is you're subtracting the X's.
Okay.
It's just not always as obvious. Do not have time to look by Starbucks today.
You have to be,
One time I found like a coupon or something that was a really good deal on like the
turn on the right side of the court,
and I'm a
turn on the left side of the court, and you have to
50 packs. 50 packs.
So like, you
Yeah,
can
and I
switch
never
your-
drank one after I made
If
those. I barely finished them before they
you're
expired.
on the right side of the court,
They're
and
so
you're
sweet.
to the right side, you have to switch.
Yeah.
I saw they have like
But
pumpkin ones now.
then you can switch out.
I tried pumpkin coffee creamer once. I kind of like throw up, so I can't.
Left heel on the right
Maybe
side.
it's just me,
Because
or maybe it was bad.
They have
but
their,
I can't do it.
forehand roll, so like, yeah, like,
Lower the power down, lower the power out one.
Seven.
If the derivative of the inside, derivative of the sine something, if you show time on thing, and you're close. It's not ready. No. Just one more step. It's bad news, so.
That's how mugs work.
Are you ready for what you didn't do? Yeah. Okay. So, why did you take the derivative of sine 4x? I'm not saying it's wrong, but why did you do that?
Because the derivative, you have to take the inside.
Derivative thing, right? But when you took the derivative of sine 4x, didn't it have an inside too? 4x,
I got negative x minus 1.
sine 4x. When you took this derivative, the derivative of sine something is cosine something. But now you need to multiply by the derivative of something. That has chain rule twice on that question. There was 2 insides.
You have to take the derivative of this. Like this inside.
Now, everything you did is fine, but you didn't do chain rule the second time. The first time, this is the inside, so you take the derivative of that. You did chain rule number 1. But then when you did that, when you took this derivative to get this, there was an inside, so you still need to multiply by 4. You can do chain rule many times as needed. That one needed twice.
It's way easier to model.
Number 16's definitely one of my favorite questions on this test review. It's a good learning experience.
That's not quite right.
I don't know.
Oh yeah, raise your hand. So you brought the power down, lowered the power by 1, and then what is this? Okay, so that's the derivative of the inside. So that's correct, it's supposed to be there. The derivative of sine something is, okay, but when you just took the derivative of that, doesn't it have an inside? Or you gotta do chain rule twice? Twice. So you're gonna still multiply by, and that changes your answer to that. That one, how do we do with the calculator? In fact, I think we did that exact question one day. If your calculator can do derivatives at a point, and velocity to acceleration says derivative. So type that in your calculator, make sure it's in random mode, and ask it to find the derivative of 1.5, and that's all you need to do.
Although I guess you could do that one by hand, but
It's from a calculator question, so.
Okay.
I heard you saying that this is where you simulations.
Yep.
Different than the goal.
Yep. So there's an inside and an outside.
And you would multiply it with that, that's.
What's the derivative of 4x?
Yeah. Of the.
Multiply it by 4x. So all that does is, yeah, but it changes your answer from this to this. Because those are just.
How do you do it?
Did Cadence Pomeroy make that?
Who?
Cadence Pomeroy?
Mm-mm.
No, she's making ones that look a lot like that. Anyway.
That was
Okay, so you can either do poetry, like they would, or you can use power.
Oh, you went by something like that. It'll take me a second. His mom made it though.
Cool. I was wondering how you do this one when there's no units in the sentences.
So you have to.
Kilometers per hour?
Or, I
Hour.
meant, labels.
Oh.
Slices.
2 divided by t, do 2 t negative 1.
That would be hard for the acceleration, that's
Yeah,
true.
and then you take the
Yeah,
derivative
I guess you can't
of
answer that part.
and you'll get
Okay.
the equation
Thank you.
Yeah. But the left, right, and at rest, you should be able to do. I thought I fixed those graphs this year, and I think it just didn't print it. I must have used the old version.
That's why I did, That was actually a calculator question. We already did that one together. But it's good for you to see if you remembered that the calculator would do it for you. You're close. You brought the power down, lowered the power by 1. You took the derivative of the inside, which would be chain rule. And that gave you this, right? But when you took this derivative, did you see how it had an inside too? So you gotta do chain rule twice. So the derivative of 4x would be 6 times 4. And now when you get this 4 to reduce with this 2, your answer moves from here to here. So chain rule a second time.
Does the square
So that's-
go inside parentheses? It has on, is it just whatever,
Top one of the questions. It's very unusual, this where the angle, but.
And for less than, greater than, you just plug in 1.5.
Yeah, all the way down the derivative 1.5. But your calculator needs to be right, because you're using the trig function. I'm not saying it's not,
Oh.
but I'm saying if it's not right,
Okay.
that number is not gonna be right.
Alright guys, hate to cut you off, but we got about 3 minutes till the dismissal bell. So again, please try the rest of these questions between now and next Tuesday. First thing when I see you on Tuesday, I'm going to ask for which questions you have. So that will be your chance to ask questions. If you haven't tried them all and you don't know which ones you really need help with, you're going to miss out on that opportunity. So this time I don't have anything you need to put in Google Classroom, so I took that off the agenda. And of course, I guess if you're feeling like you're falling behind, put in a little bit of extra effort. Don't wait until right before the test. I do have a stapler and several 3-hole punches around the room. There's only one stapler though, if you want a 3-hole punch and staple your test review.